Hey guys, Alan here, back in the workshop, and today I want to do some more prototyping. I've had this wheel cylinder which I took off a Land Cruiser in the late 1970s. It was a victim of excessive moisture in the air and hygroscopic brake fluid, but anyway. And I've had it all these years thinking it looks too useful to throw out. Its time has come. I think I found a use for it. So let's go and have a look at the mock-up and I'll tell you what it's all about. Okay, so we're over at the tool and cutter grinder, and I've got a bit of a lash up happening here, and viewers of earlier videos might recognise a couple of volunteers, a steel plate and an exhaust pipe bracket. But anyway, first thing I wanted to do is just explain why I didn't want to use the dividing head that's an accessory for the tool and cutter grinder. Basically it's just too big for what I'm trying to do, and I can't get the dimensions or the distances that I need to get the tool properly lined up, particularly when I need to do end what do you call it, end clearance, where the cutter's basically got to go in at 90 degrees. Anyway, there's a couple of scenarios where I just can't get it set properly, so that's why I'm not using that. So let's get this out of the way and then we'll have a closer look at this guy. Okay, so looking more closely at this, we've got this piece of steel with various holes drilled in it. That's always good for prototyping, the exhaust pipe bracket. So I've got the wheel cylinder mounted on the bracket, and there's just a sort of a dummy bush through there at the moment, and it's all held together. I can show you, I guess. And I can use this angle gauge to set the angles, and so we'll start off with the first step that I'll do. This is, before I go any further, I should say I'm no expert on this stuff. I've mostly used the insert tooling, so I'm interested to discover how to do all this stuff. But anyway, you've got to start somewhere. So I'll be able to, and this was just left over from a previous go at sharpening one of these things, and I've got it in mind that it will be replaced with something which allows the tool to be put in this direction or 90 degrees that way. I'm not sure about that yet, but we'll see. Anyway, so the first step would be to grind the top and side rake. I'm still coming to grips with all these terms with the top, side and front rake and clearance, but anyway, I've been working through some books. I'm sure this is second nature to the machinists who might actually be watching this, but anyway, I'll put a little diagram in when I go through this video. So the first step for me is going to be setting this up so I do the top and side rake. So the top rake is going to be 15 degrees. So obviously I can be able to set that at about 15. And we'd also do the side rake at the same time. So this whole thing is rotated around this way 5 degrees, so that when this goes in and contacts the stone, you've got to try and think in 3 dimensions here, but it'll do a compound angle which gives the top rake and the side rake in one go. So that'll be the first step, and the second step will be to turn the tool over in the holder and get ready to do the side clearance. So the side clearance, I'll need to come back this way a bit. That's going to be, depends what you're trying to cut and which books you look at, but it doesn't seem that the actual angle is particularly critical. So I'll be aiming at 5 degrees for the side clearance, and you can see how lifting this up 5 degrees would give me that clearance angle there. And then the last step will be to do the front rake and clearance. So to do that, I need to be able to present the tool bit to the stone like in that sort of an orientation. So obviously I have to turn this around but the purpose of this prototype is to just satisfy myself that it will in fact be possible to present the bit to the stone for all of the different angles that we need to and clearances that we need to get. My goal is to do all of the grinding on the flat face of the front of this cup wheel. So I'm going through all these acrobatics. It's easier if you work off the a standard flat wheel and just do it all on the curved front. And if you've got a very large diameter wheel, it approximates a flat surface anyway. But I want to try and use this stone, so that's why I'm going through all of this. So as I said, to do the second step I have to rotate the tool bit 90 degrees. To do the last bit, which is getting the getting the front rake and clearance, I'll have to rotate the jig. So I'll just check to make sure I can get it into that position. Okay, so that demonstrates the value of the prototype that you don't have any commitment to. I can't get to the position that I want to here. I can't swing this round far enough. So the only way, I was assuming that this piece here would be a fixed upright on the back side of this plate. Well, that can't be. I have to be able to do that to get anywhere near where the angle needs to be set. But with it set like that, I can actually get the angles that I want. So that'll work. So basically I'm obviously going to have to allow for this angle, this piece that the wheel cylinder is mounted on, to pivot here to give me the degree of movement that I need. One other thing I should point out, all this is being done on the assumption that the wheel will turn that way and will cut down. So the sequence of grinding that I set up was to do the top and side rake first, because that will actually grind away from the cutting edge, which isn't ideal. But then when I do the side clearance, turn this over 90 and do the side clearance, then the grinding will be cutting into the cutting edge to finish that particular edge off. So that's why I'm doing it that way. But anyway, this has been a valuable exercise, so I think this length here is about right. I don't know that I need this to be able to be slotted, but certainly I've used both of these mounting holes, so that's valuable. And certainly I've got enough height as well, because I want to grind on the centre line of the wheel. So I've got enough height on this bracket. It doesn't need to be taller than that, but it will have to swivel. So I think that's enough to go ahead and knock something up that's robust enough to actually use. This is just too flimsy and it wouldn't hold the angles. Okay, so I had a bit of an inspiration and I realised that it would be just as easy, instead of making this thing so it can move around on the plate, we'll make it so it's fixed and change the way I make this thing so that it can be, so that the tool bit can be presented to the stone that in that plane or at 90 degrees. And when that's possible, suddenly it's really easy to present the bit as it needs to be to do the front clearance and front rake. And I think I need to go back and look at the video. I think basically I can use the same hole, mounting hole here as well. I'll have to check that, so I think this is going to be a much better way to go. So I'll just make up an arrangement that allows the the bit clamp, the tool bit clamp, to be like that, or across the end, because obviously I can still rotate it around when it's like that to get that angle adjustment, and everything else still works. So yeah, I think that's the way I'm going to go. But I will go back and check. You can't see what I'm looking at, but the bolt that, oh, let's turn this around, you'll be able to see. I just can't remember for definitely whether in the previous setup where I was doing the front, doing the side and top clearance, whether I had it mounted on this hole or that hole. I'll just check that, because if it was on this one, then I don't need it to be adjustable in this direction. There's enough adjustment here. So this, you might be interested to have a closer look at this this jig actually. So rough and ready hardly covers it. So that's the spark plug socket, bit of threaded rod, and this was just a 1/2 inch square, or yeah, 1/2 inch nut, and I just welded a washer on the end of it so I could put a 5mm screw through there, and then just have that on the end of the thread. It doesn't get much quicker and dirtier than that, but it was sufficient to highlight issues and allow me to work out a solution. So I'm a fan of this sort of rapid prototyping that allows you to change things because you haven't got any commitment to the way you originally went to do it. Anyway, so I've got a way forwards. Okay, so looking more closely at this wheel cylinder, it's actually marked 28.5. That's the nominal size of the bore, but it was obviously retired from use because it was out of spec, and it's actually 28.62 at this end, 28.5 not, so it's fairly round, but just slightly out of round. But at this end it's somewhat bigger. Again, not hugely so, but I think what I'm going to do is run a 1 1/8 inch reamer through here. 1 1/8 inches is just slightly larger than the 28.5, and we'll see whether it cleans up. Now, unfortunately, I don't have a tap handle that's big enough to hold this tap formally, but fortunately a 25mm 12-point socket seems to get hold of it, so let's see how we go. I better get some lubricant, and it looks like I've got to find a better way to hold it too. It's moving around, which I'm not happy with. Okay, let's see if that's any more secure. So we'll put a bit of lubricant in there. See if we do better this time. Oops. I'm going to keep the pressure even. I think we're through, and we'll push that all the way through rather than trying to pull it back. Right, I'll pull that apart and inspect the hole. Don't think you'll be able to see from this angle anyway. So anyway, I'll get my hole gauges and we'll see whether we've cleaned the taper that was in there out a little bit. So I'll take a reading in 2 different directions, there and there, and at each end, and see what we get. Sorry that's upside down for you.
Alan, did
Thank you. But the readings that I got were that there was a 0.03 or 3,000 of an inch or 0.07 out of or change in diameter from one end to the other. They're fairly round at both ends, at each end, but there's this change in size. So obviously the wheel cylinder wore more at one end than the other when it was in service. So I might try running the reamer through it once more and see if that helps at all. I'll put a bit of stuff on here. Not sure it really needs it being cast iron, but anyway. And might take a little bit out at the tight end, and that didn't usefully improve things, so I'm going to think about sorting it out by running a boring tool through it. Okay, so these two holes here, obviously from the factory, that's where you connect the brake lines in from the back. So the bottom of the holes are profiled to match the nose on the end of the steel brake line, and they're not as deep as they could be. So I want to take them down to the almost coming through into the cylinder, so I can want to tap them out. They're M10 1.0, so it's a bit of a special thread, but anyway, I want to get the maximum thread engagement, so I'm going to take these down to I think 15 mil, something. I think that's what it is. So at the moment there, that one's 13.4, so we're taking both down to 15. Oh, that was quick and easy. So I'll just run the tap down to the bottom of those holes, but I'll do that out in the vise. So what I'll also do while I've got the wheel cylinder set up in the vise is just clean this face off a little bit. Bring the table up. It should be good enough. Right, I'm going to call that close enough for my purposes. It hasn't quite cleaned up over there, but I don't care about that. It's basically flat, that's all I'm interested in. Now, do I need to re-chamfer these holes? Maybe. So I'll just do that by hand. Okay, so this is still a bit experimental and prototyping, but the idea I've got in mind is to go a piece of angle iron, a bit like that, and where this boss is sticking out, bore a hole to be a register, and be able to mount that like that, which will allow it to pivot, and I'll be able to have a locking plate on the back of this, which engages in which is bolted to the back of this thing, and will sandwich the vertical piece here between the locking plate and this face. So that'll give me the ability to clamp it in position when I've got the angle I want. Well, let's get to it. If I don't try, I'll never know. So that bracket's got a hole right where I don't want it. So to fill that in, I parted the disc off a bit of rod, welded it in, and here you can see me cleaning it up with the face cutter, so I can get this piece to the state that I want it to be in, so I can drill the hole that I do want in the place that I want without having any issues. So I want to bore a hole in there to fit that boss, which is 37mm. So we'll start off with a 22mm hole saw, because that's the biggest one I've got. These annular cutters are really good. As a bonus, you get a slug cut out that you can reuse or use for something else. Moving through, there we go. How quick and easy was that? Let's get all this stuff out of the way. So I use the magnetic pickup tool. I find it helps having this piece of plastic bottle neck on the end, because you can, otherwise it wants to really stick, but like that you've got a bit more control, a bit easier to move it around. You can install an ejector pin to make it easier to get the slugs out, but I haven't found it to be an issue, so I don't usually bother. It's a bush in the making there. Well, and also of course when you get something like that out, not only might you be able to use it for something, it's a lot less swarf to clean up. Anyway, let's get set up with a boring head. Actually, before going to the boring burr, it occurred to me that this was an opportunity to try out using this 4-flute drill. It's actually the first time I've tried to use this for anything. It came with a batch of other stuff from an auction lot, but be interesting to see how it goes. I haven't tried to sharpen it or anything, so I've got no idea what I'm going to get. We might give it about 100 RPM and see how that works out. And give it a bit of this sort of stuff as well. Alright, let's see what happens. It seems to be cutting alright. Yeah, pretty good with that. Putting a bit more pressure on it now. Well, that worked out pretty well. I'll show you what the end of the drill looks like. Okay, so I'll just give you a close look at the end of this 4-flute drill. You can see whilst it's got 4 cutting lips, you have to put it into a hole that's at least as big as the web. The flip side is you can see that web is massive compared to the web on a 2-flute twist drill. So that's what gives it great rigidity. That 4-flute drill has a 3 Morse taper, so it has to be fitted to the milling machine via an adapter socket that converts the 3 Morse taper to 4 2040. And as you can see from the picture, the overall thing is very long, so I had to actually drop the milling table to the lowest level it would go to. Okay, so I'm not very experienced with this boring head, so I'm going to sneak up on the size that I want. It's currently sitting about 31, and I'm wanting 37, so it's 6 on the diameter or 3 on the cutting radius. Let's see if we can take 1 off the diameter. Let's turn this back around where we can see it. 1 division's 0.01 on the diameter, so in theory we want 100. 10 turns. No. 5 turns. Okay, let's try taking 5 turns. 5. Let's see what that looks like. It should be about 0.5 millimetre. There's going to be something like it. Okay, so if I've done my homework correctly, I've got this right, we should see 33.79 after this cut. Well, let's see. I think that's about it. Yeah, that's out the bottom. I'll let that back up. Wipe this out and see what size we got. We've got 33.89. Now I think the difference there is probably because I had that on an auto feed and we got a finer surface finish than we got the first time round. So we got the opportunity to take another one anyway and see if we, actually maybe it's time to start using the micrometer too. Yeah, that's out the bottom. Let's see what we got. Yeah, that's pretty much exactly what I was shooting for. 36.96. Right, well, let's see if the piece fits. Is there enough room to get that in? No, we have to drop him down. Well, it starts in the hole but it doesn't go all the way in. Why is that? Let's have a closer look. Oh, I see why. Well, we've got to go slightly larger obviously. So I think the first thing to try is doing another cut without changing anything. And we're at the bottom. That did give it a very light scrape, so who knows whether that was enough. We'll soon find out. Oh, that's nice. Yep. I'm happy with that. Okay, so we can pull that out and deburr it. Get a proper clean up happening. Alright, well that fits in there pretty much perfectly. So I'm happy with that. So with this actually in there like that, I'll be able to do some test grinding and really prove the whole thing works. I might even use this anyway, so I was thinking of this as a disposable piece just to practice making it and so on, but I get lazy sometimes, so this might make it to the finished job yet. If it does, obviously I have to fill this big hole in here, but it's not a problem if that's what I've got to do. I realised that these were the two holes that were originally in the wheel cylinder for putting the brake lines to, but I can't actually use those very well because they're M10 with a 1mm pitch, and I had one M10 one bolt, and they're like hen's teeth around here, just they're special order items. But not only that, the head of the bolt is so large that I can't actually get two of them side by side and have room for a spanner. So what I'm going to do is drill two new holes at 90 degrees across here, and just use M8s with a standard thread, so I can use a socket head screw and it'll work out a lot better. So that's the next step, drill those two holes, and then after that I'll be making up the special washer that fits here with the two holes to be the clamping plate. Okay, so I've got this set square now, as you can see, or square enough anyway. That is moving. and obviously the other way. So we're ready to drill 2 holes, or well, actually now I've got to now I've got it level, I've got to find it using the wobbler thing. Let's get this out of the way. So with the change of plan, I decided to make the clamping plate first, and then I'd be able to drill through it directly into the body of the wheel cylinder and guarantee that everything lined up. So here I'm just I've cut a rebate on the end of the bar, you can see, and I'm parting it off. Okay, so I've made a clamping plate, which will be, it's got a nice rebate to put it in position, so that'll go on there, and I'll drill directly through this. I'll drill drill directly through this clamping plate into the body of the cylinder underneath. With 2 holes to make sure it all lines up correctly. I was doing really well with the clamping plate. As you saw, it parted off nicely, but when I put it back in the lathe the other way around to clean the parting divot up, or whatever you call it, the bit that gets left behind, the stub, it flew out of the chuck and bounced across the workshop, so got a few chips and dings in it, unfortunately. Thankfully it didn't hit me in the chops, although it came fairly close. Yeah, I just got a bit careless about how I had that clamped in the chuck. Anyway, things happen. But anyway, we're good to go. So we'll put all this lot together, get set up to do the drilling. Okay, well that's it's got it close enough to start, and we'll see what the reading says. So I think we'll call that good enough. So obviously I now know I'm centered over this lump. Okay, so I'm ready to drill the 2 holes to secure that clamping plate. I'm going to drill them on a pattern that's 14.5 millimeters off the centre of the hub. Oh, and it's a 5mm hole for tapping size for an M6 screw. So I've got a bit of a lash up happening here, so I'm just using my adjustable stop, which is reasonably robust. Just basically put a restraining finger down on this disc so it can't lift up when the drill starts to break through. It's all a bit crude, but I think it'll get the job done. So that hole should be able to go through into the body, and yeah, okay, well let's give it a try. Well, that seemed to work all right. For the second hole, and I think I might just as a security blanket drop, see if I've got another one of these drills to drop in that hole. Yeah. Just to make sure it can't bloody move on me. Right, let's drill the other hole. So, tap some holes. So I've been through it with the taper tap. I'm going to run the bottoming tap through just to make sure the threads are cleared through to the end. Not that I expect my screws to reach that far, it's just good practice I suppose. Okay, so I'll do the countersink this time first. And it doesn't need much. I should imagine that would be enough. I do these smaller threads by hand, because the machine's got so much torque you just don't have any feel. I'm pretty sure I could power tap it through without any trouble, but why ask for problems? I like to have the feel. I know cast iron is supposed to be self-lubricating, but regardless of that, the tap does run in more easily, more smoothly, with a little bit of slippery stuff on it. My hands keep getting in the way. That's any better. That's a bit better, isn't it? Coming out the bottom now. Well, the taper part is anyway. So again, we'll run the bottoming tap to the bottom. So what I have to do now is open these two holes up to 6mm and we can test it and see what all works. And touch with the countersink, and I think that'll be fine. Yep, that's good. All right, let's do a test fit. This piece is upside down at the moment. It's intended to fit on the other way up, but it should work equally well both ways. So then. It's going to go on there. So hopefully these, oh yeah, that's started. Yeah, it started. That's pretty good. Okay. So that should be free to rotate around there, yep. And clamp that up. Yep, that's going to work out just fine. Okay, well as you can see it all goes together just fine, and I can swap the bits around, and it all seems to be interchangeable, so I must have my machining pretty much right, and that's a nice fit in there. It takes very little clamping pressure to stop that from turning. So let's finish that part of it, and I've got several bits left to do though. So one of them is to bore this out to get parallel bore and deal with the wear that was from its first life as a wheel cylinder. So I can hold it correctly now, hold it firmly, so that's good. Then I have to make a slug to go in there, and a face piece on here, so I can then fit another piece I've got to make, which is the tool holder with the rebate for the 1/4 inch or 1/2 inch square tool thing, and then a clamp screw to go down through here so that it'll stop it from flopping about. So there's actually still quite a bit left to do, and this video has been running for a while already. So I'm going to end this video here. Hope you enjoyed it. If you did like it, please click on the like and maybe subscribe if you haven't. Hit the bell to be told for when the next session comes up and we finish this project. Thanks for watching, and see you on the next one.